If you have noticed it in the last class, I think 1 week before, so we discussed the things like when an object is moving in a circle. So we have studied that what is the angular momentum through the center of the center of a circle. So if any object is moving in a circle, so from the center, so we all knows that in any direction, if it is moving, so always the direction, so the momentum and the direction of velocity, if you have noticed it, so always the direction of velocity will act what? Everybody. So the angular momentum MVR perpendicular, so which is always MVR. R means radius. So R perpendicular is equals to radius, which will always act what direction, everybody? We have discussed it in last class, which is equals to always upward direction. So we have studied that in any point, always, if you have noticed the velocity, so which is always perpendicular to R perpendicular, which is what is equals to R. So that is why we can say, in this case, angular momentum when the object is moving in a circular, so with respect to the center, O, always the angular momentum remains what? Constant or variable? Everybody remains it is constant. That is what we have studied. Am I right, guys? Please respond. Everyone. Correct? So now if the same body, if the body is revolving in a circular path, can you able to hear me, guys? Please respond. Now, if I have taken the angular momentum about a point
Yes,
P,
sir.
which is out of the track, about the point P, out of the track, then we have studied that at a different point, if I check it at this 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 point, so everywhere, of course, the R perpendicular, so a tangent from the outside the point, R perpendicular is always remains equal. But the angular momentum about this particular point, at every point, about this point and this point, with respect to the point P, is not same. Because magnitude is same, but what is not same, guys? Everybody? Magnitude is remains constant. What is not constant? Everyone? So direction. So at this point, angular momentum direction is acting different directions at every point. So that is why at this point it will act in this direction. At this point it will act in this direction. So that is why direction is actually it is variable. So that is why we say if any kind of object is moving in a circular track, with respect to the center, angular momentum is always remains constant. Even it is asked in JEE 2014 and 2012, I have taught you. Am I right for those? So then, if you comes to the angular momentum about this point with respect to the circle, always it is not constant. It is actually variable because magnitude is, of course, it is remains constant. What is not constant, everyone? Direction is not constant. That is why
Direction.
it is depends on direction and as well as magnitude. That is why it is called as what quantity, everyone? Who is to called as vector quantity. Clear, all of you? But the distance between from the point P to the surface, always the distance is remains constant when you draw a tangent. So that is what when in case of an object moving in a circle, so two things we have studied. So always we have studied that LO, angular momentum about the point O is remains constant. LP, angular momentum about the point with respect to this point is not constant. That is what we discussed in the last class. Am I right, everybody? And then we have started angular momentum of purely rotating body. So if you have taken a purely rotating body, so what is the formula we have derived already? Anyone? Purely rotating body. What is the angular momentum? Please respond. All of you. Mr. Rudreswar, are you there? So we all know first linear momentum is equal. So what is the formula, everybody? Please respond. R into P. So we all knows that, normal momentum.
P.
So R into P means what? Linear momentum. What is the linear momentum? Mass into velocity. So which I can take mass into R into velocity. So R into velocity, which we used to call as what? R velocity, we used to call as R perpendicular. R means R perpendicular. So that is what we have studied the linear momentum formula. So now at every point, if I taken a purely rotating body about a fixed point, that is what pivoted point. So the body is rotating with angular velocity omega. So what will happen if I choose the particles, different particles here? So that distances, let me take, this is R1 from the pivoted point, this is R2 from the pivoted point, this is R3 from the pivoted point. So at every point, this is mass M1, mass M2, mass M3. So velocity may be varies or distance from the pivoted point may varies. But every point is having the what, guys? Commonly. Every point is having the same angular velocity or angular acceleration it is. Angular. Please respond. Angular velocity. That is why I told you yesterday, please spend time on revise, but I don't know how many of you. So if I keep on doing, where we got the formula. So what is the relationship between angular velocity and linear angular momentum? Everybody. So angular momentum L is equals to, what is the formula we got, Pradosh? Linear inertia, moment of inertia into angular velocity. So this is what the formula we did.
omega.
Right, everybody? And we have solved one question also, like two bodies of having the same mass has been connected with a massless rod. So we have been derived what is the linear momentum. So I will remember, everybody, please respond, guys, all of you. So across this, like massless rod is connected, these two masses, so they both are having a same mass. So now angular momentum, so this body will goes like this direction. Definitely these bodies will come in this such a way. So we have studied that all. Am I right? What is the answer for that? Anybody can tell? What is the angular momentum? L is equals to, we got the formula. For those two different ways I have taught you. What is that? One is conceptually, another one is normally we have solved. So L is equals to, we have been done that, I omega. So if you have substituted this total length between them, see, involved in the class is very important. Namesake is attending, no use. So from the axis of rotation, it is L by 2 and this is also L by 2. So total inertia is equals to, we got it. So you can take it. What is that actually? What is the first inertia formula? R into, respond, M into R. Am I right or wrong? Everyone? Yes?
Yes, sir.
M into R1 square plus M into R2 square into omega. So both if you are substitute, we'll get it. R1 means L by 2, R2 also L by 2. We'll get L by 2 whole square plus M into L by 2 whole square into omega. So if we solve this one, we got angular momentum L is equals to, what is the answer? Please respond. Angular momentum is equals to, we got it. Everybody. ml square omega by 2. So this is what we have been done up to last class. I hope you all understanding. So keep it in mind, linear momentum P is equals to mass into velocity. Again, today also we are going to study the many things. And rotational motion. So that is what rotational momentum, or we can say angular momentum. Angular momentum symbol is what? L. L is equals to, what is the formula, everybody? Inertia into angular velocity. So this is what is you have to remember. So till now we have studied displacement, angular displacement, velocity, angular velocity, acceleration, angular acceleration. Now mass, inertia, next momentum P, here angular momentum. So what is the relations, everybody? This one, S is equals to R theta. Open your mouth. V is equals to R omega. A is equals to R alpha. Now next, moment of inertia is equals to, what is the formula? Moment of inertia is equals to M into R, and L is equals to M
M into R.
M into R. L is equals to what? I into omega. So here P is equals to mass into velocity. This is linear velocity and this is linear momentum, and this is angular momentum. So that is what you have been remember. Now we are going to study again, starts with the same formula. Let us see. This L is equals to I into inertia into angular velocity. Please keep it in mind. It is only applicable. It is only valid for symmetry object. Do you understanding, all of you? So it is only valid for symmetry objects. So the objects 90% of your class 11th chemistry, sorry, 11th physics is always, they will ask entire syllabus of your physics, they will ask you only about the symmetry objects only. So this is always a valid only for symmetric objects. Okay. So what do we mean by symmetric objects, which you already studied in mathematics? Like a sphere you can take, like you can take a cylinder, like you can take a cone, you can take a disc, you can take a ring, you can take a bat. Okay, so you can take a rod. These all are called as symmetric objects. So it is only applicable for them. Clear, everyone? So now let us see. Till last class we struggled to derive this formula. Now today's class, how we can find the linear momentum of a given system. So let us solve that. Can you able to understand, Mr. Sai Rishi? Yes, Mr. Murali, Rudreswar.
Yes, sir.
Okay. So now let us see. Let me take a rod. As I said, a rod is a what actually? Cylindrical object. Sorry, it is a symmetric object. Mr. Prados, can you hear me? Now let me take, there is a rod, all of you. So which is where the axis of rotation is passing. So we want to find the angular velocity of this one. So let me see how many of you can do. So angular velocity of this, draw the thing, everyone. So just it is how fast we can solve it. You can see that. But here momentum of inertia, the formulas also you need to know. So otherwise it is impossible to solve these questions. It's very important and very important concept for JEE and NEET also. So if you know the formulas of inertia and linear momentum, it is very simple to solve it. So we all know if it is a rod, axis of rotation is passing through the center of mass. If axis of rotation is passing through the center of mass, we all know it, everybody. So the given question is, a rod whose mass is m and having a length L. So calculate the angular acceleration through center of mass. Be very careful, it is asking. Calculate the angular acceleration through center of mass. Anybody? 1 minute time. Let me see, anybody can answer. But try to involve. It is not for you, not for me. It is only for you people. So please kindly work. Answer. Do it. Answer, Ra. Answer, Ra, Rudreswa. Okay. So I will say you. So listen, is very simple. So we all knows that what is the linear moment, angular velocity for angular momentum formula, everyone. Angular momentum is equals to, open your mouth and you can tell me. So angular momentum is equals to I into angular velocity. So now they are asking, and also one more thing you remember, I have taught you. So always remember, angular momentum and angular velocity, both are always having the same direction or different direction, everyone. Both are always having the same direction. So the direction of angular momentum, angular velocity, so both will be having the same direction. So that is also very important. Clear? So now let us see how simple it is solving. So they are asking us to find the angular momentum through what, guys? Angular momentum through the center of mass. That's all it is. Nothing is there. So we all knows that what is the moment of inertia through center of mass of a rod? Formula, please, everybody. So it is rotating like this with angular velocity omega. Tell me please, guys, everyone. Can you tell me? Everybody. Fastly, guys. What such a people? What is the inertia of a, what is the inertia? Yeah, inertia of a, inertia through the rod when it is passing through the center of mass. Yes, Mr. Prados? Yes, that is what I'm asking. I'm not asking anything new. You should tell me. So what is the center of mass? Inertia through the center of mass, moment of inertia. ml square by 12. That's all. So angular momentum through the center of mass of a rod is equals to ml square by 12 into omega. Over. That is the answer. What is the direction? Anybody can tell? Apply your right hand thumb rule. Imagine in front of you one rod is rotating. Can you tell me what is the direction of omega? Your four fingers is indicating direction of rod. Your thumb is indicating direction of angular momentum or angular velocity. Can you tell me what is that, everybody? Upward or downwards? Yes, Mr. Pradosh, Rudreswara, Narayan. Yes, you imagine that axis of rotation is this. You just apply right hand thumb rule. Rod is rotating like this. Rod is rotating like this. Your thumb is acting what direction? You apply right hand thumb rule and tell me. Everybody, your thumb is acting in the upward direction. So that is the direction of angular momentum or angular velocity, whatever it is. Clear, everybody? Understand, Amma? Please respond, all of you. So that is
Yes,
what
sir.
been taken. Okay. So next, I have taken a disk now. So I have not taken a rod now. So I have taken a disk. So with disk means we all knows that mass is not only lie on the surface. So it is throughout. Now imagine that axis of rotation is passing through the center of mass. Axis of rotation is passing through the center of mass. So with angular velocity omega. So it is a disk whose actually whose mass is m and radius is r. So can you tell me what is the angular momentum through this center of mass? Fastly, everybody. I'll give only just 1 minute time. Make it fast, guys. Don't waste time. You have to do, you have to try. So disk, what is the inertia? If you know, through the center of mass, moment of inertia over distance. Sai Karthik, Manya and Samya, are you solving? Make it quick, guys. Don't waste time. Answer it. Yes, Pradosh? So we all knows that. What is the angular momentum formula? Angular momentum through the center of mass or whatever it is. Formula is what? I moment of inertia through center of mass into omega over. So what is the center of mass of a disk? What is the, center of mass, moment of inertia through the center of mass of a disk? Anybody?
m r
Please.
square by 2.
I is equals to mr square by 2. If you don't know the
Good.
formulas, please learn. If you don't know the formula, you cannot solve anything. Over answer. So mr square by 2 into omega. That is the linear angular momentum through the center of mass. Is it difficult? That's all. So how the concepts are integrating, that is very important. Okay. Next question. Everybody has to answer. Otherwise, please leave from the meeting. No issues. I have 5 members also. No problem. I'll work because I want a good students who will work with me. It's not that nonsense. You people not at all answering. So again, I'm giving waiting. You those who are finished, you can answer. Otherwise, remain solved. So again, I'm giving the same disk, everybody. So observe. Now, axis of rotation is passing through the side. This is the axis of rotation. Imagine. Clear, Mr. Prados, what I'm saying? This is the axis of rotation. Okay, wow. So now find the axis of, find the, sorry, not I. Find the angular momentum about this axis. That is the question. Let me see. I'm giving the options also. So option A, I'm giving you 2 minutes time. Let me see how many of you will solve. You have to use it here. Parallel shift theorem. That is what it is. We already studied. Option B, 3 by 2 mr square omega. Option C, 2 by 3 mr square omega. Option D, none of the above. Not defined. So this is the question. Everybody, make it fast, all of you. Everyone has to try. What you can do it, you can. Trying is very important. Please remember. So we all knows that. What is the formula? They are asking about this axis. So about this axis, what is the angular momentum they are asking? So about this axis, in moment of inertia, if you know how to calculate it. Am I right, everyone? Please respond. So
Yes,
about
sir.
that axis, angular momentum is equals to, what is that? About that axis, what is the word to calculate? Moment of inertia into omega. That is the thing. So about this axis, what is the moment of inertia? That is very important. We already done. What is that, everyone? So if it is a disk,
ml square by
people knows. Yes, Pradosh? mr square by? Wrong, Pradosh. You are not at all following the concept. Through the center of mass. This is I through the center of mass, and this is Pargata, I through the axis, pivoted point. Do you remember? So the parallel shift. Yes, Mr. Rudreswar, the distance between them, perpendicular distance. Perpendicular distance is A. Forgot, everybody? That is what you are doing. So axis of the moment of inertia through about this axis, which is equals to what? What is the formula? Anybody? Moment of inertia through the center of mass plus m a square. Forgot? Everybody? Yes. So which is equals to, now saying not, you have to remember everything. So let me take A is equals to R. Okay. So what will happen? What is the moment of inertia through center of mass? Just now we have studied. mr square by 2. So which is equals to mr square by 2 plus m into, so a is equals to r I have been taken, so which is a square. So what is the moment of inertia across this axis, everyone? Which is already we have done only, Ra. Why
3
you
by
doing the
2
line?
mr square.
Yeah. So which is equals to 3mr square by 2. So this is what it is. That's all it is now. So what is that? So moment of inertia, sorry, angular momentum through this axis is equals to moment of inertia through this axis into omega, angular velocity. Over it is. So 3mr square by 2 into omega. Are you clear, everyone? Understanding? So please solve. Solving is very important. If you are not solving, there is no use. That's what is my question. Mr. Narayan, understand?
Yes, sir.
Yes. Yes, please try. Your trying is very important for me. That's what I'm expecting. Make it quick. I'm hearing Laksha. You can proceed. Everybody, I'm expecting answers. Mr. Rishi, Mr. Rohit, it's not necessary. If you are not involving in the class, it's not necessary. You can enjoy. Mr. Murali, you are also. There is no kind of excuse. Just namesake attending and going, no use. I know nobody is there to teach you people. So work, please. It's your future. It's not me. You have to work. Okay, so we'll go with the next one, everyone. So what is the theorem? What is the theorem we are using here in this case for finding the moment of inertia? Anybody? Which we already studied. What is the theorem?
Parallel axis theorem.
Yes, parallel axis theorem. Please learn. We have learned already parallel axis theorem and perpendicular axis theorem. So work, everybody. So always keep it in mind. A body is a symmetry. So we all knows that if the body is a symmetrical, so we can find the angular momentum. Angular momentum is equals to, what is the formula? Moment of inertia into omega, angular velocity. That's all. Please remember that. Now, let us find a solid cone. So we all people knows that a solid cone will be like this. So can you tell me what is the moment of inertia? Everybody fastly. So the angular momentum about the point. This is what is the center of mass. Center of mass, axis of rotation. So which is rotating with angular velocity v and having a length L. Having a length L. So can you tell me what it is a solid cone? Because we have a two cones. Anybody can tell me what is the two cones we have? Anyone?
Hollow and solid.
Yeah, hollow cone, another one is solid cone. It is a solid cone. So who is having a mass m, a radius r, and length L? Having a radius r and length L. Okay. So can you tell me what is the moment of inertia? We already derived. I want just formula. Turn your notebook and tell me. Everybody.
3 by 10 mr.
Yes, that's what it is, a fastness. How sharp you are is always matters. What is that? Moment of inertia about the center of mass. Everybody. Please respond. 3 by 10 m r square. This is the moment of inertia. Now I am not asking about what is the angular velocity, angular momentum of this one. So we all knows that spinning top. Do you know that our village toy where we kids when you were kids we used to play spinning toy? Everyone, please respond. So it is
Yes, sir.
example of a solid cone. Do you understand, Prados? So there will be a nail. So it will be keep on rotating. So axis of rotation. About that axis of rotation, it is being keep on rotating. So who is having a radius r? So it is only called as what? We used to call as spinning top, or we can say top toy. So which we are kids used to play. So what is that about this axis? About that axis, what is the angular momentum? Anybody can tell? It is the inverted cone, solid cone. That's fine. Both are always axis of rotation. Moment of inertia is what? Everybody. Moment of inertia is remains what? All of you. Moment of inertia is remains same. So which is equals to 3 by 10 mr square into omega. I hope you all understanding. So both are same. A solid cone is here as usual and here inverted. Doesn't matter the moment of inertia through the point, through that center, the center of mass is always remains constant. So till here finish it. Anything doubt you can ask me or else we'll proceed further. Are you clear guys? Mr. Narayan,
Yes, sir.
okay? Mr.
Yes.
Murali, yes? Anything doubt you can ask. We'll go to the next one.
Yes, sir.
Yeah. So let us take now. You should tell me. So I'm not asking. You have to tell me. So now instead of axis of rotation is passing instead of through the center of mass, which is passing through this cross at the end. So now find that what is the angular momentum and tell me fastly. So about this axis, we all people knows what is the moment of inertia. Everyone? Yes, please. Already we all people know. You already calculated. So based upon that, you tell me. Make it fast. Quick, everyone. I want you.
ML square by 3.
Very good. So what is that, everybody? So L is equals to I omega. So what is that I value about this axis, everybody? I is equals to what, guys? ML square by
3.
3. Understanding through center of mass, ML square by 12. At this axis, ML square by 3. So that's all is the answer. ML square by 3 into omega. Okay. So that's all. Okay, everybody. Understand, ma? Girls, Princey, Mane and Samya, no response, no use. Mr. Sai Karthik doing Rishi, Rohit, what is happening? I don't know. So you have to work. Please make sure you are working. I'm expecting you're all working. I don't know what is exactly. So please kindly work.
Doing, sir.
Yeah, work. Okay. Next, take a cylindrical rod. See that this is a rod actually. Oh, it's not nice. Okay, I will draw. So let us take now a cylindrical rod. It is not horizontal one. So that is very important. Vertical one. But vertical one you all studied. Do you remember, everybody? Vertical one and horizontal one also, of course, I have taught you. Do you remember anyone? Pradosh? Yes. So let me revise that concept first. If I have taken a
Yes, sir.
if I have taken a cylinder, so we all people knows that. So axis of rotation is passing through the center of mass. Center of mass, if it is rotating. So can you tell me if it is two kinds of cylinders we have? One is what cylinder? One is hollow cylinder. Another one is what cylinder? Everybody.
Solid.
Cylinder. So
Solid
if it
cylinder.
is a hollow cylinder, can you tell me what is the moment of inertia? Hollow cylinder, what is
MR square.
mr square. If it is a solid cylinder, what is the moment of inertia? Formula there is no purpose of studying. mr square
By
by
2.
mr square by 2. Clear, everyone? So this is what is a concept you all people knows. But now the same cylinder, if it has been placed horizontally, axis of rotation is passing the same way. So this is what is the cylinder now placed horizontally to you. Now still the axis of rotation is passing through the same point. So let me extend it a little bit so that it will be fine. Okay. So this is what is the things. Now you tell me, anybody. So what is the angular momentum? That is what is the question. So now cylinder is rotating like this with this. So having a length L, I will make it having a length L. So now if length L means, then this will become L by 2 and this length also will become L by 2. So we have already done. We have calculated also, Pradosh. This big derivation we have done. So can you tell me what is the moment of inertia about this axis? Fastly, anybody remember? You tell. We have been done. We have calculated also. What is the moment of inertia about this horizontal? Respond. Check your notebooks and tell me. What is the moment of inertia? Gresa, Narayan? If it is horizontal cylinder about this axis. We have calculated already. Check it. So about this axis. Yes, please. Turn your notebooks, you can be. If not, it is not. If you have really done. For those not finding out, I'll write it, you can see how done or not. MR square by 4 plus ML square by 12. We have done or not, verify it. Now you can see that. Fastly check your notebooks, you will find it. I remember.
Yes, sir.
Yeah.
Yes, sir.
That is what. Remember Rudreswar now?
Yes, sir.
Yes, sir.
That's all it is. So if you know the moment of inertia, so answer over. What is the answer now? MR square by 4 plus ML square by 12 into omega. Over answer. Clear? So this formula already we derived it. Verify it. We have derived or not? Everybody? Yes? Please respond. Clear? So please learn the derivation also. I told you it is very important derivation also. So that's all it is about it. So if it is a horizontal rod, learn everything. If it is a hollow cylinder, if it is a solid cylinder, what it is, everything you must be very familiar with that. Otherwise, it is very, very tough. Okay. So please make sure learn all the things. Otherwise, it is very difficult. Any doubt? Anybody can ask me. Clear, guys? Completed?
Completed.
Okay. So next, Mr. Kadir completed?
Yes, sir.
Yeah. Do it seriously. Everybody has to do. Mr. Sai Karthik, Rishi Ovara, Rohit, Murali. Next. So let me take a square plate or square lamina. So we all people knows that. So for this one, you only do. This is also I have taught you people. It's nothing is different like what I am teaching new. So imagine axis of rotation is passing. Axis of rotation is passing through the diagonal. So for this case, we have been done already. Verified, brothers. Moment of inertia. Okay, I will teach you. So if you are having doubt, you can ask me. So we've been done. So if it is a square lamina, so who is having a side A? So actually now this is the axis of rotation which is passing through the diagonal. So by this time I have taught you also how to calculate moment of inertia. Anybody can tell that value at least, moment of inertia. So for this case, it will be dividing into, so this is our axis of rotation. So it is making the triangle into two different things. So let me take the total square lamina. You can write it. It is the square lamina or the square plate. So whose mass is M and whose side is A. So whose mass is M means it is now axis of rotation is splitting into two triangles. So that this mass will become what? Brothers? This mass will become M by 2 and this mass also will become what? Everybody? M by 2.
M by
Yeah. And this is the triangle 1 and let me take this is triangle 2 now. So we all know they're asking what is the angular momentum about this axis. So about this axis is equals to, we all know that, into omega. So what is the moment of inertia about this axis? It is just a multiples of like this triangle plus this triangle. So axis of moment of inertia about this axis is equals to moment of inertia of a triangle 1 plus moment of inertia of a triangle 2. Am I right, everybody? But we all knows that is it equilateral triangles? Moment of inertia of triangle 1 is equals to moment of inertia of triangle. Speak loudly, guys. Moment of inertia of triangle 2. So we all studied already. So if I cut this one, if I take this triangle, so we all knows that if the axis of rotation is passing through a base, axis of rotation is passing through a base. So just I'm rotating and I'm making. So axis of rotation is passing through the base. So the height of the triangle, H is equals to, we have been calculated. H is equals to what is the value? Udreswa? So that is what is the diagonal. H is equals to what is the value? Everybody, please respond. H is equals to, we have been already done. Just to see the same triangle, I'm just making horizontal. Yes, Pradosh? Or else you tell me about the baseline. What is the moment of inertia about this baseline? Yes, please. Moment of inertia about the baseline. Fastly, guys. mh square by moment of inertia. We already done. Check your notebooks. If you done only, it can be. So I is equals to mh square by 6. Now we all know, we already calculated h value also. What is the h value formula, Pradosh? Side is square of lamina. So a root 2 by 2. Verify in your notebooks. That's why yesterday I told you to revise. If not, nothing. You have done or not, Rudreswar? Verified. So axis of rotation, axis of moment of inertia about this axis, both are equal. So can I write this one as a 2I delta because both triangles are same. So I'll substitute the value 2 into. So moment of inertia means m into r. So what is the value? Check it.